So today's video, our transformation is going to be the dilation. Dilation is when we are going to change the size of the object but keep the same shape. We're going to enlarge it or we're going to reduce it. So the key about the dilation is we have the same shape but different size. When we look at that, we have two choices. We're either going to have an enlargement or a reduction. Those are going to be our two options here. What we're going to do is we're going to dilate each figure under the indicated terms. So if I see my coordinate notation here, x, y, this says 2x, that says 2y. That tells me that I'm going to multiply each x by 2 and I'm going to multiply each y by 2. So I'm going to get down to my coordinates down here, and I want to find those original points. So coordinates of A, I'm at left 3, up 5, so I'm at negative 3, 5. B, we're going right 2, up 5, so 2, 5. And C is at negative 2, positive 2. From here, according to my directions, this tells me I'm going to multiply each of my x's by 2 and each of my y's by 2. In order to keep the same shape, but just change the size, I have to multiply the x and y by the same number. I would never multiply x by 2 and y by 3. So if I multiply my negative 3 by 2, I'm at negative 6. 5 by 2 gives me 10. I'm multiplying each of these numbers by 2, giving me negative 4, positive 4. So let's go ahead and graph our new picture. Negative 6, positive 10. This is the image of A. 4, 10. This is the image of B. And negative 4, positive 4. That's the image of C. So we have to make the choice, is this an enlargement or a reduction? When I look at my figure there, I can see that it's going to be an enlargement. Our original image got bigger, our original figure got bigger as we multiplied everything by 2. So if I multiply by a number greater than 1, I'm going to have an enlargement because I'm going to be making that object bigger. When I go to number 2, this time it tells me that I'm going to multiply each of my values by 1/2. So even before I were to do this, I would know that I'm going to have a reduction anytime we multiply by a number between 0 and 1. So a fraction between 0 and 1. So let's just have that number be A. Anytime we multiply by any number between 0 and 1, it's going to be a reduction. And we can see that now. We look at our original points. A is at negative 2, 8. We went left 2, up 8. B, we went right 10, up 8. C, we went right 8, down 5. Now, we're going to multiply everything again by 1/2. So half of negative 2 is a negative 1. Half of 8 is 4. Half of 10 is 5. Half of 8 is 4. Half of 8 is 4. Half of negative 5 is the negative 2.5. So we've got a decimal there. That's okay. We go ahead and plot these new points. So negative 4, positive 1. That's the image of A. 5, 4. That's the image of B. And 4, negative 2.5. So halfway between 2 and 3. That gives us our image of C. And you can see after you've plotted your points that our image is smaller than the original. So if the image is larger than what we started with, it's an enlargement. If it's smaller than what we started with, it's a reduction. And the number with x is telling you what you're going to do. What do you multiply every x by? What do you multiply each of your y's by? So if we have a dilation, if it maps 1016 to 2032, what are the coordinates of the image of 15, negative 10 under this same dilation? So the first thing we have to do is figure out, how did I go from 1016 to 2032? In dilations, we're always multiplying by some number. So what do I multiply by 10 to get to 2? I multiply, or by 10 to get 20, I multiply by 2. To go from 16 to 32, I multiply by 2. Every single time, the x and the y have to be multiplied by the same number. If you don't multiply by the same number, you're changing the shape and it's no longer a dilation. So if I want to do the same dilation, I'm going to take this and I'm going to multiply each coordinate by 2. So 15 times 2 is 30, negative 18 times 2 is a negative 36. So for these kind of problems, you want to find out what the dilation is, what dilation multiplier do you have, and then multiply that to your new points. Our last one, triangle DEF, so we're starting with DEF, is enlarged to triangle ABC. I'm making it larger, which means I am multiplying by a number to make it bigger. What are the coordinates of the center of dilation? If you see our lines coming through, we are dilating it over the origin. The coordinates of the origin are 0, 0. You want to be very careful because sometimes I'll ask you what is the name of the center of dilation, and the name of the center of the dilation is the origin. But in this case, I asked you for the coordinates, which is just 0, 0. The similarity factor, the similarity ratio, if I'm going from DEF to ABC, it is a enlargement, so I'm getting bigger. I look at corresponding sides. DE corresponds to AB. They're in the same location. Think about parallel lines corresponding, same location on the other object. And that's 10 to 50. Well, I reduce that fraction to 1 to 5. So our similarity ratio is 1 to 5. The original has a size of 1, and the enlargement was enlarged by a factor of 5. So the similarity ratio is 1 to 5. It's 5 times bigger than the original. All right, and that is it for your dilation video.